The planet Mars. Not the Mars of today, but a future Mars. A world of seas, continents, and vegetation. A place to live. To remake the red planet in Earth's image will require engineering of the boldest order. For clouds to sail in breathable air, that's the challenge. To transform a frigid global desert into a place where water flows and plants begin to grow. But more than that, to establish life on Mars would end uncertainty. For the first time, we'd no longer ask, are we alone in space? Right now, this is the only place we know life to be. Yet, when the spacecraft Galileo swung past Earth, it detected just one hint of life. Lots of oxygen. Galileo saw a moon and a planet, no animals or plants. With different sensors, of course, Galileo would have seen cities. The nightlights of America's west coast. And Florida, surely the lights of life. From Earth, we wonder at lights of a different kind, the stars and galaxies of the cosmos. Our own galaxy, the Milky Way, is home to billions of stars, millions of them ordinary stars like our sun. Nobody knows, but it's fair to assume that many of those stars have planets, and where there are planets, there's potential for life. If that life is intelligent, we should be hearing from it. That's the reasoning of radio astronomers. With great dishes, they listen for signals from beyond. Depressingly, after years and years, there's been not a peep. Yet radio telescopes provide the only hope that something will be heard. And they tell astronomers that the chemistry of life is out there. It floats in clouds of gas and dust throughout our galaxy, complex organic molecules like the molecules that gave rise to life on Earth, to humankind. Earth is a small planet of an insignificant star in the suburbs of our galaxy. As we look inward at the 200 billion stars of the Milky Way, surely there's life out there. It's in the nature of our species to journey outward, to explore. Continent by continent, we colonized the world. Now we're contemplating space stations, bridges to the planets. Sooner or later, we'll reach them. And maybe we'll develop technology to carry us onward, across light years of space to the stars. For the present, we search for life with simpler means, the instruments of astronomy. Already, an observation from Earth orbit has sparked excitement. Scientists were looking for stars so young that disks of material still surrounded them, halos from which planets might form. Here, in a great cloud of gas and dust, 1,300 light-years from Earth, the Hubble Space Telescope made a remarkable discovery. It was searching in the Orion Nebula. There it is, Hubble's picture of a star surrounded by a black cocoon of dust. Was this how our solar system developed? In time, will this star shine bright and clear when planets are formed from the disk? Billions of years from now, will one of those planets develop life? Will intelligent beings stare out into space? Will they too wonder, are we alone? Even for a star with planets, there's no guarantee of life. Take our solar system. Nearest the Sun, Mercury, scorched and barren, impossible for life. And at the other extreme, farthest from the Sun, it's too cold and dark for life. Pluto is out. So are the gas giants like Neptune and Uranus. The same for Saturn. There are more likely planets, like Venus, virtually the twin of Earth, and Mars, our smaller neighbor. But as we know, life developed only on Earth. The question is, why? Let's go back to the origin of the solar system. 4.5 billion years ago, as the Sun began to shine, the planets were born out of the disk that swirled about it. The infant Earth was a compact little world, like Venus and Mars, formed from the heavier elements of the disk. But it was a place we'd never recognize. Other than a thin crust, Earth was a molten ball. It seethed with heat and energy, volcanoes everywhere. The first atmosphere was poisonous gases. As they rose, they cooled, clouds formed, it rained, and then there were seas. It rained and rained for millions of years. Eventually, oceans covered 4/5 of the planet. Earth was a world transformed, but still without life. Rain did the trick. Over eons, organic molecules were flushed from the atmosphere. The oceans became a broth of organic matter. Then, about 3.5 billion years ago, probably in warm, shallow waters, molecules began to replicate. They started to take in nutrients, even to use sunlight as food. Life on Earth had begun. As the volcanoes quieted down, the atmosphere cleared and changed. More and more oxygen was pumped out by green plants as they evolved. When the first animals crawled from the sea, there was good air to breathe. Our benign and beautiful planet had evolved. Today, in the process we call photosynthesis, plants continue to convert sunlight into food and to replenish our atmosphere with life-giving oxygen. The world teems with life. But what was the trigger? What was the catalyst that sparked such life on Earth? Increasingly, scientists believe life on Earth may have been triggered by organic molecules carried here on comets. Perhaps, but then why not on Venus? Just as many comets have fallen there as on Earth, yet Venus is devoid of life. And why not on Mars? Next to Earth, Mars is the most likely incubator of life. We know it once had water. There are polar ice caps to prove it. And volcanic peaks point to an exciting past. This one, Olympus Mons, is over 15 miles high, the tallest mountain in the solar system. The Martian volcanoes have long been quiet, but once they fueled an atmosphere like that of the early Earth. If Mars had a similar geological past, why not a parallel biology? These are our own volcanoes. They're on the Galapagos Islands. Stripped of life by computer, they look, for all the world, like the surface of Mars. So why do the Galapagos swarm with life when back on Mars we find only sterile desert? We're skimming along Mariner Valley, a rift that would stretch from New York to California. If Mars had oceans, this would be a great waterway. The ice caps of Mars shrink and grow with the seasons. Some of the ice is frozen carbon dioxide, but there's water ice too. It supports a theory that water once flowed on Mars. But if it did, what went wrong? There's more evidence of a watery past in photographs from space probes. Here, a network of channels. And a teardrop, molded surely by flowing water. So how did Mars become a desert, rusted red by iron oxide? One idea is weak gravity. The planet is only half the size of Earth. Because Mars couldn't hold its atmosphere, it leaked into space. No problem, so long as volcanic gases replaced what was lost. But when eruptions ceased, Mars was in trouble. The protective blanket of water vapor and carbon dioxide, which trapped the sun's heat, disappeared. Mars lost its warmth and its water. Almost certainly we will land on Mars in time. We will build permanent stations on Mars. After all, the trip from Earth will take a year. We will need airtight shelters. The wispy atmosphere of carbon dioxide is unbreathable. Explorers will wear pressurized suits and drive Martian rovers. They'll search for water. Reservoirs of ice are thought to lie beneath the surface. And they'll take samples for evidence of life. Fossils, perhaps, or microbes still surviving in the dirt. The big plan will come even later. The dream of turning Mars into a second Earth. To transform Mars, generators would be built to release vast quantities of carbon dioxide. As the atmosphere thickened and warmed, water would appear. Released from permafrost and the polar caps, it would form seas. the greening of Mars would be underway. Everywhere, specially sown plants would pump out oxygen. Imperceptibly, there'd be an atmosphere to breathe. Mars in the image of Earth. The process would take thousands of years, and it's still science fiction. But on a terraformed Mars, imagine a cruise along Mariner Valley. In its waters, our descendants could gaze at reflections of Martians, reflections of themselves. Venus, Earth's other neighbor. Did life ever develop here? In size and density, it's the twin of Earth. Forever shrouded by cloud, Venus, until recently, concealed its nature. Now, thanks to space probes with radar, we've glimpsed the surface. The awful truth is revealed. Venus suffers the ultimate runaway greenhouse effect. With an atmosphere 96% carbon dioxide, the sun's heat is trapped. Venus is an inferno. To this day, these are the only pictures of the surface. They were radioed to Earth before the landing craft melted. The rock was basalt, probably slabs of lava. Radar mappers painted a better picture. They electronically pierced the clouds to give the first wide-angle images of Venus, and volcanoes were revealed. But this was a flatter planet than expected. There are fewer craters and less contour than on Earth or Mars. The surface is like an ocean bed, smoothed by currents. Radar had more delights. Stripped of its cloudy veil, we could now fly low over the surface of Venus. This is the topography of Venus, a computer enhancement of radar data. Heights are exaggerated and color guessed at, but otherwise the features are accurate. Craters, evidence of missiles from space. These pancakes are volcanic eruptions crushed by the atmosphere. Pressure here is 90 times greater than on Earth. A mile-high volcano, probably extinct. Of all the planets, Venus has the most volcanoes. It's also hell. Temperature, 900 degrees. Visibility distorted, winds and lightning storms, and when it rains, it may pour sulfuric acid. We have much to learn of Venus. Why does it rotate the opposite way to Earth and Mars? What makes it an inferno? There's never been life on Venus. There probably never will be. A probe descends into another cloudy world, the gassy colossus of Jupiter. The search for other life continues. After the sterility of Venus and Mars, this is the next place to look. Although Jupiter is nearly 500 million miles from the Sun, it's not a frigid ball of gas. As this infrared image shows, there are bands of heat radiation. Jupiter emits more energy than it receives. But the tops of its clouds are cold, more than 200 degrees below zero, and they're laced with poisons like ammonia and methane. It's a hostile place. Yet lower down, temperatures rise. Complex organic molecules are known to be present. Some scientists suggest that the chemistry and energy here resemble the conditions on Earth when life took hold. Might this be a birthplace like Earth? Do organisms float in this Jovian soup? Another possible incubator of life, the great moon Europa, one of 16 that orbit Jupiter. Beneath a thin, icy crust may flow a global ocean where perhaps volcanoes erupt. As in our own oceans, creatures may cling to volcanic vents, feeding on chemicals, thriving in darkness. Even farther from the Sun, we'll also probe this bland facade. Enveloped in smog and mystery, it's Titan, a planet-sized moon of Saturn. Beneath the haze, scientists believe that Titan has the chemical prerequisites of life: hydrocarbon snow and methane lakes. It's like the Earth in deep freeze. But one day, they say, Titan may come alive. 5 billion years from now, Titan will thaw. The Sun will begin to die and become a red giant, boiling away the oceans of Earth. But here, for a time, life may spark and flourish. And who knows, Titan could become a lifeboat for the human race. By then, Earth will be a cinder. In the short term,